Chapter 2 is reasoning and proof. Starting in section 1, we're going to talk about patterns and inductive reasoning. Inductive reasoning is reasoning based on patterns that you observe. So if you look at these first three terms in this sequence, in this pattern, you can see that each one is a figure, a polygon, inscribed in a circle. Well, the pattern here that we can observe is that the first polygon inscribed in the circle is a triangle, then a square, then a pentagon. So using our reasoning skills, we can assume that if this circle contains a 3-sided polygon, this circle contains a 4-sided, 5-sided, the next two are going to contain 6-sided and 7-sided. So it will look something like this, where a 6-sided hexagon and a 7-sided septagon is inscribed in the same circle. So we can figure out the next two terms in the pattern, the next two pictures or images that should be drawn using our inductive reasoning. Now, a conjecture is a conclusion that you reach using inductive reasoning. So you're going to figure out the pattern, and your conclusion from using inductive reasoning is called your conjecture. So this example is asking, what conjecture can you make about the sum of the first 30 even numbers? So write out a table, write out some examples, and try to look for a pattern. 2 is the first even number. So there's one term. The sum is 2, which, if you think about it, is 1 times 2. For two terms, 2 and 4, the sum is 6, which can also be written as 2 times 3. 3 terms, sum is 12, can also be written as 3 times 4. 4 terms, the sum is 20, it can also be written as 4 times 5. The pattern that we're noticing here is that each sum is the product of the number of terms, so here the number of terms is 1, and the number of terms plus 1, so 2. The next example, there's 2 terms, 1 more than that is 3. 3 terms, 1 more than that is 4. 4 terms, 1 more than that is 5. So we notice the pattern here that however many even terms times 1 more than those terms gives you the sum. The number of terms times 1 more than those terms gives you the sum. Therefore, we can make the conjecture that the sum of the first 30 terms, the sum of the first 30 even terms, is 30 times 31, which is 930. So the same as these simple examples, when there were 4 terms, we did 4 times 5. Here it's asking for 30 terms, so we can do 30 times 31, which is 930. So if this makes sense, try number 3. What conjecture can you make about the sum of the first 30 odd numbers? Write down the question, try to make a table in your book, and figure out the pattern being made there. Pause the video and unpause it when you've completed. So here we can notice that when there's one odd number, the sum of 1 is 1, which is the same thing as 1 times 1. When it's 2 odd numbers, 1 plus 3 is 4. 4 is the same as 2 times 2. 1 plus 3 plus 5, that's 3 numbers, which is 9, and that's the same as 3 times 3. So when you are asked what the sum will be when there's 30 numbers, no matter what those numbers are, the sum of them is going to be equal to 30 times itself, the number of terms times the number of terms. So we can say that the conjecture we can make of the sum of the first 30 terms is that it's going to be 30 times 30, which is going to give us 900. So you can say that in order to find the sum of a certain consecutive odd numbers, however many terms, is that number of terms squared. And in this case, when there's 30 terms, we get 900. Finally, we have making a prediction. Given the information here, the sales of backpacks at a nationwide company decreased over a period of 6 consecutive months, which is shown here. What conjecture can you make about the number of backpacks the company will sell in May? Well, the points we can see are decreasing. Now, the graph shows the number of sales decreasing by about 500. Not exactly. We're just making a prediction. We're not looking for exactness here. So from 11,000 to a little above 10,500. From about 10,500, about 500 down again. Here the decrease is a little steeper, but it's approximately 500 each time. So from this, we can make the prediction that come May, it's going to decrease about another 500, which would bring us to selling approximately 800 backpacks. So you're just basically seeing the pattern that's being showed in the graph or table or the information given, and making a prediction about what will happen in the future if it follows along the same pattern. Finally, we have counterexamples. Counterexamples is something that we've been doing for a while, but just to give it a name, a counterexample is an example that shows that a conjecture is incorrect. So, just as an example, let's say you're being told, you're given the conjecture that you can connect any 3 points to form a triangle. We want to show a counterexample to prove that that's incorrect. So, obviously, if we have 3 points, sometimes we can absolutely connect them into a triangle. But as a counterexample, what would happen if those 3 points were collinear? If they're collinear, meaning if they fall on the same line, we can't connect them into a triangle. So this shows that this conjecture is false. You cannot connect any 3 points to form a triangle.